Since 1967 there has been the Outer Space Treaty, which prohibits all countries from claiming territory on celestial bodies. However, in 2015 Barack Obama, concerned that the treaty was hindering space exploration, took advantage of the fact that the 1967 agreement did not explicitly ban commercial activities. He signed a law allowing United States private companies to extract resources in space. And currently, the legal framework permits the sale of resources extracted from space exclusively to companies based in the United States and Luxembourg. But what was the purpose behind the adoption of these laws? What resources are being targeted for extraction from space? And how soon can we expect this to begin? For the past 50 years, crewed missions to the moon have been grounded due to economic infeasibility. However, not only is the mission to send astronauts back to the moon set to be realized within the next 3 years, but there is also an ambitious goal to achieve breakthroughs that will propel science forward. Artemis 3 is a collaborative endeavor between NASA and SpaceX, aimed not only at testing new technologies for transporting humans to celestial bodies, but also at the extraction of helium-3 for Earth. This mission will mark the first commercial flight to space in history. Helium-3 is a fascinating variant of ordinary helium, distinguished by having one less neutron. Due to the moon's lack of atmosphere, helium-3 accumulates in lunar regolith. To harvest this valuable resource, plans are underway to establish a lunar processing base that will extract the gas from the soil and transport it back to Earth. Currently, its price stands at an astonishing $17,500 per gram, or 500,000 per ounce. But why is that so essential for us? Because it promises to revolutionize energy production. Helium-3 can be utilized in nuclear fusion, and the byproducts of its decay are non-radioactive, meaning a fusion reactor powered by it could be environmentally clean. Moreover, thanks to this, the advancement of medicine will accelerate. And due to the scarcity of helium-3, the improvement of quantum computers is hindered. The moon is not just a small object that every inhabitant of Earth has gazed upon in the night sky. It holds the potential for a treasure trove of resources waiting to be discovered. What other wonders might it conceal with its silvery surface? The most widely accepted theory regarding the moon's formation is the giant impact hypothesis, which posits that about 4.5 billion years ago, during a time when the solar system was still highly unstable, around 40 young planets were orbiting the Sun. Among them was a planet named Theia, which collided with the Earth. The aftermath of this cataclysmic event saw the two bodies merge into one. Debris from this collision was flung into orbit around our planet, and under the influence of gravity it coalesced to form the Moon. Remarkably, the Moon now holds a treasure trove of resources, including those from both Earth and Theia. Everything we extract from our planet can also be found on our lunar companion. Many people argue against the money being funneled into the costly organization of lunar mining. However, there is an important nuance to consider. Unlike Earth, the Moon lacks an atmosphere, which means there is nothing to pollute. On the other hand, terrestrial mining severely impacts our quality of life as we continue to harm our planet and ultimately ourselves. That's precisely why space companies are vigorously engaged in testing resources extraction on other celestial bodies. The most promising and realistic target right now is Mars. However, it's possible that there are sources of highly valuable resources there as well. The challenge lies in the fact that the cost of delivering just 1 kilogram of cargo to Mars is around $100,000. Experts predict that in the future the extraction of basic, non-rare resources will primarily be sustained by the planet itself and its moons. For now, transporting anything mined from Mars only makes sense if something extraordinarily valuable is discovered. A frequent proposal is to establish mining operation on asteroids. Various minerals and volatile elements found within the rocks of asteroids or comets could serve as sources of iron, nickel, and titanium. Furthermore, it's believed that some asteroids contain water-bearing minerals, which can be transformed into water and oxygen, essential for sustaining life, as well as hydrogen, a key component of rocket fuel. As we continue to explore the cosmos, the utilization of space resources will become indispensable. Though the time is not quite upon us yet. We are on the brink of a new era, one where we extract resources from space, much like our ancestors once colonized distant continents. In the next 5 years, we will witness the emergence of the first colonies beyond Earth. Goodbye.